In question number 16, equations of two travelling waves in a medium is given as y1 and y2, where x is in centimeter and t is in second. If column 1 contains equation of another travelling wave y3 and column 2 contains characteristic of resultant wave yr, then match the correct options. So if I find out, so I can see that y2 can be written in form of sine, then it can be written as sine 100 pi t minus 2 pi x plus pi by 2. So it is ahead of y1 with a phase of pi by 2. So if I find out the resultant of y1 plus y2, then it comes out to be 8 sine 100 pi t minus 2 pi x plus pi by 4. So this is y1 plus y2. Now if I consider the first entry of column 1, y3 is equal to 8 sine 100 pi t plus 2 pi x. So if I see this function and this function, both are sine function and their frequency are same. Resultant of y1 and y2 is moving in positive x direction and y3 is moving in negative x direction. Their amplitudes are same. So they will form standing wave. So in case of a standing wave, the intensity varies as a function of position and not as a function of time. So entry P of column 2 is wrong. It is not a travelling wave, it is a standing wave. So T is correct, and the maximum displacement of medium particle from its mean position is 2 times 8, that is 16 centimeter. So R and T is the correct matching for entry 1. If I check the entry 2, it is written as 8 cos 2 pi x plus 100 pi t. So further it can be written as sine 2 pi x plus 100 pi t plus pi by 2. Then in that case, again they are in opposite sense, so they will form standing wave. So RT is the correct matching. In entry 3, it is given that y3 is equal to 6 times sine 100 pi t minus 2 pi x minus pi by 4. So it is also a sine function, frequency is same. So if I take the reference frame of sine 100 pi t minus 2 pi x as this, then the resultant of y1 plus y2 is here at an angle of 45 degree and the amplitude is 8. And if I draw the y3 on this, then it is at an angle of minus pi by 4 from the reference frame and of amplitude 6. So this is 6 let, and this angle is also 45 degree. So if I translate this vector to this position, this is 6, then the resultant is this, and the value of resultant is 10. Then this angle is 37 degree, and this angle is 8 degree. So in this case, if I write the resultant yr, that is y1 plus y2 plus y3, it can be written as 10 into sine of 100 pi t minus 2 pi x. Since the phase is positive, so in terms of degree I can write in 8 degree, or I can write in terms of radian. So this is the progressive wave, it is a travelling wave, and in case of a travelling wave, average intensity is uniform at any point. So the correct matching for entry 3 is QS. Let's move to entry 4. y3 is equal to 8 sine 102 pi t plus 2.04 pi x plus pi by 4. So if I see y3 and the resultant of y1 and y2, then their frequencies are different. So due to difference in frequency, their superposition will generate beats. So the maximum amplitude in case of beat will be 16 and minimum amplitude will be 0. So the correct matching will be P and R. So the correct answer for question number 16, for entry 1 it is RT, for entry 2 it is RT, for entry 3 it is QS, and for entry 4 it is PR. Let's move to question number 17. In question number 17, column 1 contains different charge configurations and 2 points A and B. Column 2 contains potential difference between points A and B, that is VA minus VB. Match the entries of column 1 with those of column 2. So first entry is A long wire along z-axis having linear charge density plus lambda, and points are this. Now I have to calculate what is the potential difference between A and B. So we know that VB minus VA is equal to minus RA to RB into E dot dr. So suppose the uniformly charged wire is along z-axis, then the electric field at a distance r in the xy plane can be written as lambda upon 2 pi epsilon naught r into r cap. This is the vector. If I take the dot product, that is dr into r cap, this is E dot dr. And if I integrate from A to B, so the distance of A, since the electric field in the space is parallel to xy plane, so there is no requirement of z coordinate. So RA is equal to 5 and RB is equal to 10. So the integration limit is from 5 to 10, and negative of this, it is equal to VB minus V. So if I solve this, the value of VB minus VA comes out to be minus lambda upon 2 pi epsilon naught into ln2. So the value of VA minus VB will be positive. So the correct matching for entry 1 is R and S. Let's check the entry 2. A long wire along z-axis having linear charge plus lambda for z greater than or equal to 0 and minus lambda for z less than 0. Since the z coordinates of point A and B are 0, so the points lie in the xy plane. So if I take the positive z-axis on which there is a linear charge density of plus lambda, then due to this at any point, suppose if I consider this point, the electric field due to outward wire is in this direction as well as in this direction, and the value of this vector is lambda upon 4 pi epsilon naught r at a distance r. If I consider the wire along negative z direction, due to this the electric field is in this direction as well as in this direction. So the net electric field is along negative z direction, and it is equal to 2 times lambda upon 4 pi epsilon naught r, that is lambda upon 2 pi epsilon naught r into minus k cap. Since A and B points lie in the xy plane, so dr vector is perpendicular to E vector. So I can say that the xy plane is the equipotential surface for this electric field. So VA minus VB in this case is 0, and the correct matching will be T. Let's move to the entry 3. 3 large non-conducting plates having surface charge densities on one surface only plus 2 lambda minus lambda and lambda. So if I calculate the electric field at point A, then electric field at point A is 2 lambda upon 2 epsilon naught in this direction. Electric field intensity due to a non-conducting sheet having uniform surface charge density sigma is equal to sigma upon 2 epsilon naught. So sigma in this case is 2 lambda. So I am writing 2 lambda upon 2 epsilon naught in this direction. Due to minus lambda is also in this direction. So lambda upon 2 epsilon naught in this direction. And due to plus lambda, it is in opposite direction. So minus lambda upon 2 epsilon naught. It is in this direction. So this gets cancelled out. So the electric field is lambda upon epsilon naught in this case. So the electric field at point A, is lambda upon epsilon naught in this direction. Then electric field intensity at point B is 2 lambda upon 2 epsilon naught in this direction minus lambda upon 2 epsilon naught in this direction, and lambda upon 2 epsilon naught is also in this direction. So I am subtracting this. So the electric field at point B is 0. So the electric field in this region is 0 and the electric field in this region is constant. So if I want to calculate the potential difference between A and B, so it can be written as lambda upon epsilon naught into 2D. So the correct matching will be P as well as S. Let's move to entry 4. A hollow conducting shell having surface charge density plus lambda. So VA minus VB in this case can be written as, so potential at this point is KQ by D because it is at the surface minus KQ by 2D. So it is equal to KQ by 2D. So if I substitute the value of Q and K, it can be written as 1 upon 4 pi epsilon naught into 1 upon 2D, and the value of Q is lambda into 4 pi D square. So on solving, it comes out to be pi D upon 2 epsilon naught. So the correct matching will be Q and S. So the correct answer for question number 17, for entry A it is RS, for entry 2 it is T, for entry 3 it is PS, and for entry 4 it is QS. Let's move to question number 18.